Hi everybody, this is Unit 2 Video 6. It's an introduction to arc length and area of a sector. Both arc length and area of a sector were topics that you learned about when you were in geometry class, but we only were able to measure angles in degrees, so we're going to have to extend that to our radian measurements. Let's take a look. The first topic, arc length, is going to be symbolized by the lowercase letter s. Arc length is a measurement of the circumference, or a portion of the circumference. Our circumference formula, 2 pi r, represents the distance around the entire circle. If I'm given an angle theta and a radius r, we're going to be able to calculate the arc length of a portion of the circle. If theta is measured in degrees, then we can go ahead and use the entire circumference formula multiplied by a portion of the circle, where theta is in degrees. Let's look at this example as if that were 90 degrees. If we place 90 in the position for theta, we would have 90 over 360, which reduces to 1/4. It's 1/4 of the circle. So I would want 1/4 of the entire circumference, 2 pi r. This is when theta is measured in degrees. If theta is measured in radians, we get to use the shortened formula, which is just going to be r times theta. So this one we use, it's new, for theta in radians. The area of a sector is the area of a shaded region of the circle with a central angle. Once again, we need to know that angle and we need to know the radius of the circle. For the area of the entire circle, we would use the formula pi r squared. Again, if we only wanted to find a quarter of that, or a portion of it, we would place the angle measured in degrees over 360. And this would be the formula we used in our geometry class. However, if it's measured in radians, we're going to be using area of the sector to equal theta divided by 2 times r squared. And this is the new formula if theta is measured in radians. Notice for area, r is squared, whereas for arc length, r is not. It's squared representing a two-dimensional region, whereas arc length could be measured with a piece of string or a straight line, and that is why r is not squared. Let's try some examples. I'm going to give you an example of arc length, or finding arc length in both radians and in degrees. Let's start with degrees. The radius of the circle we're working with is going to be 4 inches. And our angle measure, our central angle, is 120 degrees. We're going to use the formula for circumference, which is 2 pi r, and we're going to multiply that by theta over 360 to give us the portion of the circle we're looking for. We can no longer call that c because I don't want the whole thing, so we're going to call it s for arc length. So I'm 2 times pi times 4 inches times 120 over 360. If I want an exact value, I'm going to have to multiply the 2 times 4 times 120 and divide it by 360. I'm not going to touch the pi key because that will give me some decimal approximation. So with an exact answer of 8/3 pi inches, if I want an approximated value, I would take the 8/3 and I would actually multiply it by the pi button in my key. I don't want to use my calculator. I don't want to use 3.14 because that's an additional approximation, which would kind of be like rounding twice. So my approximated arc length would be 8.38 inches. For the next one, I'm going to give you a radius of 7 feet and an angle measure, a central angle, of 7/4 pi. So we'll go ahead here and we'll use the shortened formula, which is just going to be r times theta, which is 7 times 7/4 pi. Again, if I want an exact answer, I would leave this as 49/4 pi feet. For an approximated answer, I would multiply 49/4 times pi using the pi button on my calculator, and I would get 38.48 feet. Let's try area of a sector. For the area of a sector, again, I'll give you one measured in radians and one measured in degrees. We'll start with the one measured in degrees. if the radius of our circle is 11 meters and our theta, our central angle, is 240 degrees, I want to find the area of the region formed by that central angle. My area of the entire circle is pi r squared, but I only want a portion of it. I want 240 out of the 360 degrees. So I'm going to place my 11 squared and 240 over 360. Again, for an exact answer, we're not going to touch the pi key. So I have 11 squared times 240 divided by 360, and I will turn that into an improper fraction. And I have exactly 242 thirds pi meters squared. This is a two-dimensional measurement, so we will use squared. My second example, I'm going to give you the radius measured as 6 yards and a theta, an angle measured in radians, at 2/3 pi. Let's go ahead and calculate that using the new formula, which is theta divided by 2 times r squared. So I'm going to place my theta 2/3 pi. Now, to represent the divide by 2, I'm actually going to use a fraction of 1/2 times 6 squared. And that's going to save me from dealing with a fraction within a fraction. So once again, I'm not going to press the pi key, but I'm going to multiply 2 divided by 3 times 1/2, or I can use 0.5, times the 6 squared. And that gives me 12 pi yards squared. Then I will go ahead and multiply my 12 by pi using the pi key to come up with 37.70 yards squared. And there is my answer for my area of a sector.